All right, so last but not least, here we go. Example 3. Right, can you tell bottled water from tap water? So now we're going to use cumulative binomial probabilities and we're going to make some decisions. So it says Mr. Bullard's statistics class did an activity to see if students could tell bottled water from tap water. Okay, so again, the taste, right? There were 21 students in the class. Each student was given 3 cups, 2 that contained tap water and 1 that contained bottled water in a random order. The student was asked to drink the cups of water in a specified order and then to identify which cup contained bottled water. If we assume that the students in Mr. Bullard's class could not tell tap water from bottled water, then each one was guessing with a 1 out of 3 chance of being correct. Okay, so again, this is important, right? 1 out of 3 chance because one of the little cups contain bottled water. So 1 out of 3 chance of being correct. Let x equal the number of students who correctly identified the cup containing water when guessed. So this is our random variable. And again, I'm assuming it's going to be binomial because you either get it or you don't. Each kid's independent. There's your probability. And there were 21 students who guessed. 13 made correct. So their value that actually happened was 13. So that actually happened, right? So the question is, are you convinced, or there's that word convinced. Are you convinced that Mr. Bullard's students could tell bottled water from tap water? Compute the probability that x is greater than or equal to 13 and use the probability stats, using the probability stats applet, and use this result to support your answer. Okay. So again, I think this is a binomial situation. Again, as we go through the bins, right? You either guess it correct or you don't. Independent, each student's guess is independent of the next one, right? No student affects the other one. There is a p-value, the number of students doing this is 21, and your probability of being correct is 1/3. So we're going to use this to graph the distribution, and then we're going to calculate using the binomial probability stats app at the probability of x being greater than or equal to 13. So again, remember when you do this, you usually go less than or greater than the value. You include the value, of course. So if we get greater than 13, that would just give us more of a convincing argument that they know the difference, right? Okay, so we're going to add up all the probabilities from 13 and above. All right, so let's do this on our stats applet. So I'm going to go here. Stats applets, probability. Again, make sure you choose the correct one. We are looking at the binomial distribution. So our n value is 21 because 21 students, and our p-value is 1/3. Don't round because that's not nice. And there we plotted the distribution. So now over here, look, right? This is 10, 11. Let me write on it. This is 10, 11, 12, 13, 14. And then look, there's like nothing. So if we look at 13 and above, right? X is greater than or equal to 13. Notice there's a very small probability. So let's see what we're going to get. Okay. So now down here, it talks about you can calculate the probability. We want the probability of greater than or equal to. Now notice that's not a choice, right? Now more than is, but we don't want more than because we want equal to. So greater than or equal to means that 13 could be the least amount, but we could be more. So this is at least 13. And we go. And notice, look what it did. It shaded in red the probability of 13, 14, and again, nothing else. And there's your probability, 0.0068. So what in the world does that mean? Well, let's go back to our notes and let's talk about it. So when we use the stats applet to calculate the probability that the number of people we get correct would be greater than or equal to 13 was 0.0068. We are going to write down 2 sentences, right? So now, first of all, what is this as a percentage? That's just 0.68%, not 68%, 0.68%. That's a very, very, very small percentage. So we are going to write, there is about. So this is just us like talking about what happened. There is about a 0.68% chance that 13 or more students out of 21 would correctly identify the bottled water. So that's the percentage by chance, right? Simulated percentage. So now when you see this convincing evidence, you should be thinking of 5%, right? If something happens very rare by chance, then the fact that it actually happened has meaning, gives us convincing evidence, shows that they really do know the difference. So because this only happened 0.68%, that's way less than 5%. Therefore, there is convincing evidence that Mr. Bullard's, I'm going to come up here, that Mr. Bullard's students could tell bottled water from tap water. And again, that's because 0.68% is way less than 5%. And there we go. And we could put a 0 in front of the 0.68 to emphasize. Nice. Okay, so very similar to our other convincing evidence questions, just again needing to use the stats applet for the cumulative probability. All right, hopefully this worked out okay and you do a good job on the homework. All right, ask questions if you have them.